let's start the class now. See, I will not turn on your camera. See, we had done about the work and we had seen about the positive work. We also observed that the positive work when there is action of force. Okay. So are in this direction, then you have a positive work. You have a negative work. We will say that the work done is negative when the displacement is opposite to the direction of the force. Right? So in that case, we say that it is a negative work done. And in the life, we come across such a force that is the force of friction. The force of friction itself does not do any work. Okay? So force of friction, it does not do on its own, it does not do any work, but it always opposes motion. Okay. So since it always opposes motion, so all the motion which will occur, so friction force will be acting opposite to the direction of motion and hence opposite to the direction of displacement. Okay. So one of the best examples that you can give for the negative work is the force of friction. Then we had seen about the zero work done. The cases when there will not be any work done, that is a zero work done. Zero work can happen in various cases. Like, for example, if the force is zero, if there is no force acting on the object, but there is a displacement, so in that case, the work done will be zero. Okay. So if the force is zero, the second case is if you apply the force, but the displacement is zero. There is no displacement. So in that case, also the work done is zero. For example, you try to push a wall with all your will, but it does not move. There is no displacement, so no work is done. Then the third thing we talked of the zero work done, as when the force makes 90 degree with the displacement. So force is perpendicular to the displacement. That is another case where we can have a zero work done. So in this case, it is zero work done as no part of the force is utilized for the displacement. No component of the force is utilized for the displacement. So therefore, in this case, there will be zero work done. Right? So I gave you one of the example of circular motion. So is there which force acts in the circular motion? Which force acts in the circular motion? Yeah, for any object to have a circular motion, which type of force we discussed is required? What was the name given?
Sir, gravitational force.
Yeah, the name given was the gravitational force. So in the circular motion, there is gravitational force which is required. So you have the requirement of gravitational force. Right? In the circular motion, you require the gravitational forces. So therefore, in the gravitational force, you have the gravitational force will be measured by the formula. Gravitational force or the centripetal force. For the circular motion, we require the centripetal force, not the gravitational force. The gravitational force is provided only by the gravitation. Okay. It is the centripetal force which is required by an object to move in a circle. Okay. The centripetal force may be provided by a thread. It may be provided by the gravitation. It may be provided by magnetic forces. It may be provided by the electrostatic forces. Like I will give you various examples for them. Okay. So see, what are the various examples we can look at? For example, one of the examples I told you, one of the examples I gave you was that Okay, so one of the examples that I give about the circular motion was suppose you
Sir,
try.
sorry, I joined late. I was in the bathroom. I just came.
Okay, so we are just having an introduction of what we discussed in the last class. Okay, we discussed about positive work, negative work, zero work. Okay, we are now discussing about the
Okay,
circular
sir.
motion. Okay, so in the circular motion, we had discussed about the centripetal force, and centripetal force is the force that always act towards the center. Okay, the force that act towards the center of circle, and it is required for an object to be moving in a circle. So force that act towards center of circle. That is the centripetal force. So like if any object is moving in a circle, so if an object is moving in a circle, it requires the centripetal force. So the centripetal force, either you can provide it using a thread. For example, if you whirl a stone tied to a thread in a circle, if you are whirling that, so in that position, you are providing the centripetal force using the thread. Okay, you are binding the stone using the thread, and hence the force that is being provided is by the thread. The thread tightens up, and that force we call as the force of tension in the thread. Now, similarly, we have just studied in the previous chapter about the structure of atom, right? So, in the structure of atom, when we had discussed about the structure of atom, so one thing was discovered over there. In the structure of atom, we came to know that the nucleus is at the center of the atom, and the electrons revolve around the nucleus. Okay. So in that case, when the nucleus is at the center of the atom and electrons revolve around the nucleus, so since electrons, see here, again an example, the nucleus is at the center, the negatively charged electrons, they are revolving around this nucleus in circular orbits. So if they are revolving in circular orbits, so they must require some centripetal force. Okay, and that centripetal force is provided by the electrostatic forces of attraction between the nucleus and the electron. Here we can say that the nucleus is holding the electrons. Here the nucleus is holding the electrons with the electrostatic forces of attraction, right? So centripetal forces can be provided by various means. And if you observe in the nature, so we observe Earth orbiting around the sun, right? So Earth orbiting around the sun, the Earth requires a centripetal force, and that centripetal force is provided by the gravitational force of sun, right? So everyone understood this about the gravitational forces?
Yes, sir.
So in the circular motion, basically we see that the force always act perpendicular to the displacement, and therefore in the circular motion, the work done is zero. Okay? Work done by the centripetal force is always zero. So therefore, work done by the sun in revolution of the earth is zero. Therefore, the work done by the nucleus in revolution of the electrons is also zero. Okay. So I hope everyone has understood these all the 4 points of the work. Okay. Now there is another important thing. Let's see. So in very few of your courses, you also find this. Let's have this surface, and on this surface you have a briefcase or a luggage lying over here, or a box lying over here, such that the box has a hook like this available over here. It has a handle available over here. Now if you are pulling this if you pull this box, so you are applying some force like this. If you are applying some force in this direction, at a direction, but the box is actually moving in the horizontal direction. Right? I hope all of you must have seen such briefcases. Okay. So have you seen such briefcases in which a handle is provided over here? You apply a force at a certain angle to the displacement. The box is displacing along horizontal direction,
Sir, but the
and there is some
there are
displacement.
wheels on the suitcase.
Yeah,
There are wheels on the suitcase, so it just
yeah,
moves.
there are wheels on the suitcase, and you apply the force something like this. Okay. So in this case, what happens? Now your force is not acting in the direction of displacement. It is not perpendicular to it. It is also not opposite to it. Rather, it is making some other angle. Okay. So in this case, as we can observe that all the force is not being utilized for the displacement, only a part of the force is being utilized for the displacement. Okay. So some part of the force, it is utilized for lifting this box. Okay. So we can assume this force to be acting along two directions, and hence this force can be studied to be taken under two directions. Some part of the force is being utilized to cause the displacement in the horizontal direction, and some part of the force is being utilized to lift this portion. Okay. So this force, some part of it is utilized to lift it, some part of it is utilized to perform the displacement. Now, in such a case, the work done is calculated by the formula Fs cos theta. Fs cos theta, where F represents the force, S represents the displacement. And Chavan Kaushik, did you take the test?
Sir, no, the website was not showing the PDF. For
No,
some
it was
reason,
there.
the PDF is not working, sir.
Huh?
I sent a message on the support team as well. To the support.
Okay, see. So, just wait for 1 minute. Wait. There is just an urgency. I'm Let's continue now. Here we had discussed that if the force acts making some angle with the displacement, so in such a case, the work done is given by F as cos theta. Okay. Where theta is the angle between.
Sir, are you going? Okay. Did you
Yeah.
cover trigonometry basics for physics in other class?
No, that is
No,
not to be
that is
covered.
not to be covered.
Right now, you need
Right
not
now, you
cover
need
that
not
part.
cover that part. Then how are you able to use cos theta and everything since you didn't cover the
See,
basics in class?
see. This you will
This you
study
will
in your
study in
grade
your
10.
grade 10.
Okay.
Okay.
Right now, you
Right now,
just,
you just
if they
if they
just,
just
Chavan, turn off your
turn off.
mic, mute your mic. Okay, see. So right now, wherever the values are required, the values of cos theta will be provided to you. Okay. In the question paper only, it will be provided to you. So theta is the angle between force and displacement. Okay, so cos theta. What does this cos theta represent? It is a trigonometric ratio, and for various values of angle, it has various values. For example, if the angle is 0 degree, so cos 0 degree is equal to 1. Okay. If the value of this theta is 60 degree, so we have cos 60 degree given by 1 by 2. Similarly, the value of cos 90 degree is given as 0. Okay. So generally you can remember any three of them. These three you can remember, or they will also be provided in the question paper. Right? Cos of 0 degree is 1, cos of 60 degree is 1 by 2, cos of 90 degree is 0. Okay. Now using this, just can you do one question? I'm giving you to solve here. Let's see. A force of a force of 30 Newton acting at an angle of 30 degree of 30 degrees to the displacement, acting at an angle of 30 degrees to the displacement, displaces it by 10 meter. Find the work done. So can you tell the work done?
Sir, I just joined the class because like I have exams, so I don't know what's happening.
Okay. See, even if you have your exams, okay. So how many hours of class do you have? 1 hour class every day?
Yes, sir.
Okay. So try to give it. Okay.
Yes.
So that's good
Sir,
you have
is
joined.
it 300 or 150?
This is your cos 30 degree, and I give you the value of cos 30 here.
Cos 30 is not given, sir.
So that's what I'm giving. Cos 30 is equal to
1 by 4.
no, it's under root 3 by 2. So I just said 1.73 divided by 2. This is the value of cos 30 degrees. You can put this value and obtain the answer. Okay,
Sir, it's
so
259.8.
259.8. Okay, so your answer of work done will be given by force, which is 30 multiply displacement 10 and multiply cos 30, which is root 3 by 2. So you can cancel this 2 with this 30, it will become 15. So you get 150 root 3. Okay, and root 3 is 1.732. So you can multiply that and you get this as the joule.
Wait, sir, but you put cos 30 over there as 1.732 by 2.
So that 1.732 is the same under root 3.
Okay.
Okay, so you can even multiply this, you will get the same thing. Multiply this 150 by 1.732. That's 259.8. Okay. So I think, John, you are getting the same answer.
Yes,
Sir, I'm getting different values, sir.
Okay. Who is getting a different value? Prince?
Sir, Abhinav.
Abhinav. So what happened? Abhinav, where are you wrong?
I did the same thing, sir, like 150 into 1.732, but I'm getting a different answer.
Okay.
Okay, wait, I got it, sir.
What you have done?
So it's just my calculation mistake, sir.
Okay, fine. So you can improve your calculation. Now let's see. Up to now we have understood what is work. Okay. Now let's move to the next part of this chapter. That's energy. Okay. So we define energy as the ability to do work. So our next part of the chapter is energy. See, energy and work, they are interrelated to each other. How they are related? That if you want to do any work, so to do work, you must require some energy. Okay. So we define energy as the ability to do work. So energy is the ability to do work. Okay. So whatever ability we have to do work is called as the energy. Now in ourselves, we observe energy to be in different forms. Like suppose if I did just giving you small examples. Suppose if your mom says to push a box to some side, okay. In your home, you have a box which is to be pushed aside, so you can push that easily, right? And suppose if the same box is allowed to be pushed by some small kid of around 3 years, okay, and if the box weighs around 50 kilograms, so maybe the kid will not be able to push it, but you will be able to push it. Okay, this is because you have a more amount of energy than the small kid. So what does the energy measure? Energy is the ability to do work. How much of the ability we have to do the given amount of work, to do the work. That is that is the energy. So we observe different types of work and different types of energies are also available around us. If you see the different types of energy, we observe the heat energy. Okay, and we observe that the heat energy is utilized to do a lot of work. The heat energy is utilized to cook food. The heat energy is utilized to move vehicles. The movement of vehicles is caused by the heat energy. Okay. So the different forms of energy which we observe around us, let's see different forms of energy. So in the different forms of energy, the very first one I list is the heat energy. So heat energy is utilized for movement of the vehicles. Where do we use the heat energy? Do we use it for movement of vehicles? For cooking food? Okay. So for movement of vehicles, for cooking food, for all this we require the amount of heat. Okay. We also see heat is required in various other terms. As we know that the first railway wagon or the first engine that was made was the steam engine. Okay. And the steam engine was based on the heat energy.
Coal.
Okay. The next one is the solar energy, which we are utilizing every day. So solar energy is the energy obtained from the sun that we call as the solar energy. And what is it being utilized? So it is utilized by plants, right? It is utilized by plants to prepare food during the photosynthesis. It is utilized in solar cells. Okay, we use solar cells to generate electricity. Right? So these are the various forms of energy. We also have another form, that's the sound energy. Can you tell any applications of sound energy? Yeah, can anyone tell any applications of the sound energy?
Sir, I don't remember the exact ones, but I
In the
remember.
science field.
Okay, first of all, it causes hearing. Can we hear without the sound energy? Sound is an energy because of which we are able to hear it.
And sound is caused by compression, frequency, and all that.
Yeah, so all that, but it is a form of energy and it causes hearing. We are able to hear anything, that's because of the sound energy. Okay. It can also be used as switch. A sound energy can also be used as a switch. Okay. There are various other uses of the sound energy. We'll come to know about the sound energy. Then apart from the sound energy, you have some other sources of energy.
Mechanical energy.
Yeah, we have mechanical energy. So that mechanical energy is given by,
Potential energy plus kinetic energy.
yeah, the mechanical energy is termed as potential and kinetic. It exists in two forms, either potential energy and kinetic energy. These are the two forms of the mechanical energy. Then we also have chemical energy. The energy which is stored in the form of chemicals, in the form of bonds between them. So chemical energy is the energy possessed energy in the chemicals. Okay. Energy possessed by the chemicals in their bonds, that is the chemical energy. And where do we see? Why do we eat food, or how is food able to provide us energy? How can we say that the food is able to provide us energy?
When the food is utilized, like
So,
the digested food
can,
is utilized by the
okay. See, the food we eat, it has chemical energy stored in it. So when we eat that food, we digest it, and from the food, the chemical bonds break to release energy. Okay, so over there we can say that the energy is stored in the form of chemicals in the food. Also, we have learnt about cells, right? So cells store, as we know that the cells can provide you electrical energy. So cells, they store electrical energy in the form of chemicals, right? So yeah, from this you can also get the definition of the cell. What is a cell? It is an equipment which stores the electrical energy in the form of chemical energy. Then we also have electrical energy. So where do we see electrical energy?
Switchboards, electricity.
Yeah, it is the electricity. So it is used in bulbs to produce light. It is used to run speakers to produce sound energy. Okay. It is also used to run fan and various electrical appliances. Like your electric motor and all electric motor, electric geyser, all of them run by the use of the electrical energy. We have another one, that is the solar nuclear energy. This is now one of the modern energies that has been found out. So nuclear energy is the energy stored in the nucleus of an atom. Energy stored in the nucleus of an atom. Okay, so these are the various forms of energy. You also have another form. Can you name? We have light energy. Light is also a form of energy. So these are the various forms of energy. Nuclear energy, light energy, sound energy, heat energy. All these are the various forms of energies which are available. Okay. So why we are studying this, all the forms of energy? Okay. So yes, beta. So Prince, what are the different forms of energies? Can you tell?
Sir, heat energy, solar energy, sound energy, mechanical energy,
Mhm.
chemical energy, electrical energy, light energy, nuclear energy.
Okay. If I ask you that what is the ultimate source of energy on the earth?
Oh,
Ultimate source of energy. That if their source is not there, we will not be able to get any other form of energy. Anyone can tell? Can anyone tell what is the ultimate source of energy?
Sir, it's either light or solar. Like I guess
is it
sun,
solar, so
Yeah,
it
solar
should be.
energy is
solar.
the solar energy is the ultimate source of energy for the earth. Now, See, all these are the forms of energy, right? If we see the total energy in the universe, it remains constant. The total energy is constant. It can just transform from one form to the other. Energy always gets converted from one form to the another form, right? So somewhere it might get converted from heat energy to light energy. Somewhere the solar energy may get converted into chemical energy, and that chemical energy may be converted to heat energy. So there is just a change of energy from one form to the other form. Like if we observe the process of the photosynthesis, so in the process of photosynthesis, what is happening during the process of photosynthesis? There is just change of energy. And how the energy changes? It is the solar energy which is absorbed by the solar energy is absorbed by the plants. So that is the conversion of solar energy into the chemical energy, right? And what the plants are doing, because by using that they are preparing the food. And just now we have discussed which energy is there in food. Prince, which energy is there in food? Siddhisri, which energy is there in food?
Sir, chemical.
Chemical energy. In the food, you will find your chemical energy. So chemical energy is there in food, right? Food has the chemical energy. So therefore, we say that solar energy has got converted to the chemical energy. Okay. And when we eat that food, so that food by the respiration, it gets oxidized to produce energy. Okay. So that is again a conversion of energy. The chemical energy is getting converted into heat energy. Okay, now let's see a small circuit and try to identify what are the different energy conversions that are taking place. I hope you will be able to get this. So this is a battery and it's connected with a bulb. Okay, so can you give the energy transformations that are taking place? Pranaya, can you tell the energy changes which are taking place?
Yes, sir. First, there's chemical energy here.
Okay, so this cell has the
Yeah.
chemical energy,
Yes, sir.
right?
And then it's being transferred from the wire to the bulb, which gives us light. So maybe it has electrical energy.
So first, okay, from the chemical energy, it is getting converted to electrical energy. Okay. And what you are getting from the bulb?
Light. So maybe that would be solar energy.
No, that's light
Light
energy.
energy. Okay, okay. Yeah.
So from the bulb, you are obtaining the light energy, right? Chemical energy getting converted to electrical energy and electrical energy getting converted to light energy, right? So, okay, one more I would like to ask you, what are the energy changes that are taking place? You will respond to it. Again, the same way. Suppose in the same thing, I attach a speaker. Suppose a speaker is attached. So here I attach a speaker. So what type of energy is conversion is taking place now? Abhinav, can you trace the energy conversion?
So where again?
In the circuit, you have used a speaker, or just tell what is the energy conversion that takes place through a speaker.
From electrical energy to sound energy.
That's very good. It gets converted from electrical energy to sound energy. That is what we say as energy conversion taking place in a speaker. can you talk of what is the energy change that takes place in the mic? Can you explain the working of a mic then?
I think it works on the same principle, right? It just amplifies our sound. It takes our sound from sound energy to sound.
Yeah, it
No,
takes
sir,
your
it's
sound. So it starts with the sound energy,
then electric energy.
then electrical. So isn't it different?
It is kind of different, sir.
It's different.
Here we,
It's converting your sound energy to electrical energy, right? Okay. See, you are talking of amplification. So that amplification is performed by an amplifier, which is an external device, and it works on the electrical energy, right? You require electrical energy for amplification. But of course, your sound energy is getting converted first into the electrical energy, which is getting amplified. Okay. Let's say, so I think now you will be able to trace the energy changes. Let's trace out, we will trace out some other energy changes once we understand the mechanical energy. Okay. Mechanical energy is very important from the point of aspect of physics. Why? For physics, mechanical energy is very important, that all the other energies, solar energy, sound energy, electrical energy, nuclear energy, almost all the other forms of energy, they can be described in terms of potential energy and kinetic energy. All such energies, they can be described in terms of potential energy and kinetic energy. So that is why mechanical energy occupies a very important position in the physics. Now let's see first what is potential energy and kinetic energy. So anyone knows what can we say about the potential energy, or what is potential energy?
Potential energy is like energy of object when it's not moving, like it's at a particular height or something.
See, uh, getting to the proper definition gives you a proper idea of what is potential energy. So we say about the potential energy, or any object can possess a potential energy. It is just due to two things. Either due to change of configuration. Potential energy is the energy possessed by a body due to change of configuration, or you can say just because of its configuration. Let's say energy possessed by a body I think no one is getting bored. Is there anyone who is getting bored?
no, sir.
No, sir.
If you are getting bored, so I can give you some questions then. Okay. So potential energy is the energy possessed by a body due to its position or configuration. Okay. Configuration means it's either change of shape, structure. So if an object possesses any energy because of the change of the shape, because of the change of its structure, okay, or if an object possesses any energy because of the change of position, so that we call as the potential energy. So how we observe this potential energy, as it should be able to do some amount of work. So we observe potential energy in the case of bow and arrow. For example, a bow, okay, an inflated balloon, okay, water in a tank. So all of them, all the examples which have been given, they all possess potential energy. Okay. So we will continue with the discussion of these in the next class. Okay. Till then, revise this and we'll come again in the next class. We'll be completing this chapter. On this Saturday, you will be having a test from these. Okay. Is there anyone from you who has submitted me through WhatsApp? Any test submitted to me through WhatsApp? Okay. Bye everyone. Good night.
Bye, sir.